Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 3450, Mission to Mars, Lecture 9, the International Space Station. In Lecture 8, we talked about the history of the Space Shuttle program. In this lecture, we'll talk a little bit about the history of space stations in orbit around the Earth and spend a little bit of time on the International Space Station. The International Space Station is the place where we are for the first time really learning to live and work in space for long periods of time. Therefore, it's worth learning a bit about the space station because it has direct bearing to living and working on a Mars mission, which could take up to 3 years. So let's talk about the history of space stations. Von Braun imagined a space station back in 1952 as a giant spinning spacecraft in orbit around the Earth. Its spin would provide a centrifugal force that would provide an artificial gravity for the astronauts living on board. This type of space station inspired Stanley Kubrick in his 2001 A Space Odyssey to imagine the giant spinning space station depicted in that movie. Now, this was such an important and influential movie that as one of the upcoming homework assignments, I'm going to ask you to watch this movie and look at things that they got right and look at things that they got wrong about space stations and how spaceflight would proceed. Most impressive is that 2001 A Space Odyssey came out in 1968. The first idea for an orbiting space station came out of the Gemini program, and it was called the Manned Orbiting Laboratory. This was essentially a military project. The goal here was to launch a rocket with an upper stage that served as a space station connected to a Gemini capsule. They would cut a hole in the heat shield of the Gemini capsule. The Gemini astronauts would crawl through that hatch into the space station, and then they would live and work on board this space station for many weeks or months at a time. Now, it was a partly classified program because the goal here was for the crew to conduct optical reconnaissance of the surface and electronic intelligence from orbit around the Earth. Studies of the Manned Orbiting Laboratory began in the early 1960s. It was publicly announced in 1963, but eventually the program was canceled without ever flying a single astronaut into space in 1969 because it was realized that robotic, uncrewed reconnaissance satellites could do the same thing for far less expense. The very first space station that was launched into space was Salyut 1, and that was launched by the Soviet Union in April of 1971. It was a civilian space station. After Apollo 11, the Soviet Union had lost the race to the moon. They decided to focus their efforts not on the moon, but on building space stations in Earth orbit. And Salyut 1 was the first of those. So it was the first true space station. It had one docking port. The Soyuz 10 mission in April of 1971 attempted to dock with Salyut 1 and could not because of various technical issues. They were able to soft dock with the station, but they couldn't hard dock, and they eventually had to abort and return to Earth. The first crew that spent any time aboard Salyut 1 was Soyuz 11 in June of 1971. There were 3 astronauts on board Soyuz 11, and they set the space endurance record for the time of spending 22 days in space. Now, tragically, the 3 astronauts were killed on re-entry when a pressure equalization valve opened on them, and the atmosphere inside their Soyuz capsule was allowed to bleed out into the vacuum of space, and they could not close the valve fast enough, and they could not don protective gear fast enough, and the 3 of them suffocated from the lack of oxygen. After Salyut 1, there were other Salyut stations. There was Salyut 2, which is also known as Almaz 1, and Salyut 3, Almaz 2, and these were military space stations. These were largely tasked with optical and electronics intelligence reconnaissance of the surface of the Earth. Salyut 2 failed in orbit, but Salyut 3 was visited by Soyuz 14. Soyuz 15 attempted but could not dock with it. And then came the first U.S. space station, and that was Skylab. Now, Skylab was developed as part of the Apollo program. As the Apollo program was beginning to wind down, NASA was concerned that the workers who were working on the Apollo program would leave NASA and go find other jobs in aerospace. So they studied various projects. They studied a lunar base. They studied an Earth orbiting space station, a grand tour of the solar system, a giant robotic mission to Mars, a space telescope mission, and they were all classified as part of the Apollo Applications Program. And ultimately, the one that came to fruition was Skylab. In 1970, and it flew in space from 1973 to 1979. So the construction of Skylab began in 1969. What they did was they took the upper stage, the third stage of a Saturn V rocket. You'll remember that's the Saturn IVB stage. They took that upper stage and they converted it into an orbital lab. They put 2 docking modules on it so that 2 Apollo command and service modules could be docked at the same time. They put an airlock on it for extravehicular activity so the astronauts could go out for spacewalks. They put a giant telescope mount on it, which had a giant ultraviolet and a giant solar telescope. Total mass of the space station was 88,000 kilograms, and it was launched on May the 14th, 1973, on the very last Saturn V rocket to ever fly, and it was placed in a 440-kilometer or 273-mile circular orbit. The goal for Skylab was to have a large area where the astronauts could live and work for long periods of time, and docked to it would be the Apollo Command and Service Module. This was how the astronauts would get to the space station, and they would, of course, return home on the command module at the very end. Skylab was launched May the 14th, 1973. You can see the modified Saturn V rocket here. The third stage was now the space station itself, and then there was just this nose cone covering the space station to protect it on launch. Unfortunately, during launch, one of the micrometeoroid shields on the outside of Skylab was torn away. That shield, as it was torn away, tore off one of the 2 main solar panels. The other solar panel was then tangled in debris that consisted of a metal strap and some wiring. When Skylab got onto orbit, it was realized that there were significant problems with the space station, and it was quickly reoriented so that the solar arrays that were part of the telescope module right here would be facing towards the sun so they could generate as much electricity as possible. But one of these 2 giant solar arrays was torn away, and the other one was prevented from opening up. Well, NASA hatched a plan to rescue Skylab. The first thing they had to do was very quickly sew additional thermal blankets that would replace the micrometeoroid shield. See, that micrometeoroid shield not only protected the space station from impacts from space debris, either man-made or micrometeoroids, but they also provided shade for the space station, and they kept the hot sunlight off the interior where the astronauts would live. Without that micrometeoroid shield, the interior of the Skylab space station was experiencing extraordinarily high temperatures. To deploy this heat shield, they developed a plan that the astronauts would go inside the Skylab. They would dock with Skylab. They would go inside Skylab, and there was a scientific airlock, and they would open that airlock, and they would deploy out of the airlock a giant, essentially telescoping umbrella that would replace the torn-off micrometeoroid shield and would shield Skylab from the bright sunlight that was heating up the interior. Now remember, Skylab was launched on May the 14th. Just 11 days later, on May the 25th, on the Skylab 2 mission, they launched the first 3 astronauts to Skylab. They were Commander Pete Conrad, science pilot Joe Kerwin, and pilot Paul Weitz. So this crew was supposed to launch a day after Skylab, but because of the issues that were encountered with Skylab, they waited 11 days. But in those 11 days, NASA and its engineers devised a fix for Skylab, constructed all those blankets, loaded it on the spacecraft, and launched the Skylab 2 mission. Now, the interior of Skylab was soaring up to temperatures of 126 degrees Fahrenheit. That's 52 degrees Celsius because of the loss of that sun shield. So this first crew had to solve that problem because they couldn't live in temperatures of 126 Fahrenheit. Because they were only going to low Earth orbit, they didn't need the full power of the Saturn V rocket. So they launched on a rocket called the Saturn I, which consisted of the second stage of a Saturn V rocket, but they had this special first stage, and it was much, much shorter than the Saturn V rocket. So it was launched from this top of this tower here. In fact, when they were going to launch Skylab, They were launching Skylab from a pad that was right next to where Skylab 1, which was the lab module itself. It was right next to the launch pad where they were launching Skylab 2 with the astronauts. And you can see the comparison between a Saturn V rocket and the Saturn 1 that was used to put the astronauts in low Earth orbit. Well, when they reached Skylab, they flew around Skylab and they surveyed the damage. They soft docked to Skylab. And they did a spacewalk. They evacuated the air out of the command module. They opened the hatch on the module, and Joe Kerwin stood up inside the command module and tried to free the trapped solar array with a 10-foot pole. And that was unsuccessful. They weren't able to free it that way. They eventually decided to go ahead and dock with Skylab. It took 8 docking attempts to eventually dock with Skylab. And once they got inside Skylab, once they docked with it and got inside, they deployed that parasol, that umbrella, through the scientific airlock to shield the space station from the sun and started cooling off. About 2 weeks later, they did their spacewalk, and on that spacewalk, they freed the stuck solar array. And for the next 28 days, the crew made repairs to Skylab. They conducted scientific experiments and medical experiments. They did Earth observations, and they made observations of the sun. And then they came back to Earth. So here are just some pictures of what they found when they got on orbit. So here you can see the Skylab station. Here you can see where that solar array was torn away. You can see some stray wires that should not have been floating free. And then here you'll notice this solar array that was stuck and could not open because of this metal and that wire that were holding it closed that the astronauts had to cut away. This is what it eventually looked like after they deployed the parasol to protect the spacecraft from the bright sun, and they were able to get that solar array to deploy, but of course the other one had been torn away. Skylab 3 was launched in July to September 1973. Commander was Alan Bean. The pilots were Owen Garriott and Jack Louisma, and they did 3 extravehicular activities. They installed an additional sun shield on the outside, and they spent 58 days at Skylab. They also did some experiments inside. They did, for the first time, living 58 days in space. They were the first crews to do experiments with long-term living in space. They tested a backpack that astronauts would be able to use, a maneuvering backpack that they might be able to use outside the space station for maneuvering around. Here they are at the controls of the telescope mount. So this is the mount that they used for controlling the big telescope outside so that they could point it. I love seeing the old Polaroid photographic camera right there, the old Polaroid camera that they could take pictures with. This is what it looks like after they deployed their modified sun shield. So you'll notice underneath the original sun shield that was deployed out of the airlock, on one of their EVAs, they deployed this additional sun shield, and that kept the interior of Skylab nice and cool. The final mission to Skylab was Skylab 4 from November of 1973 to February of 1974. Commander was Gerald Carr, and then the 2 pilots were Ed Gibson and Bill Pogue. They did a total of 4 extravehicular activities, 4 spacewalks. They spent 84 days in space. And we learned a lot from the Skylab 4 crew about scheduling the crew and how to handle crew psychology. This was the longest space flight that the United States had conducted up to that point. In fact, it was the longest space flight to that point. They learned a lot about working in microgravity. They learned a lot about how to design the environment that the astronauts were working in. They learned an awful lot about the workload expectations that they were putting on the astronauts. The astronauts were being asked to take days off. They were falling behind schedule. It was taking longer to do tasks that NASA wanted, that Mission Control wanted them to do. And so they were being asked to take their days off, and instead of using a day off, use those instead to get caught up on their work. None of the crew had flown in space before, so none of them knew what to expect. And there was no transition period, no time to allow them to get ready. They literally docked to Skylab and were expected to get to work right away. NASA learned a lot from this mission about how to keep crews happy and how to make them more productive in space. Probably the most important thing I would argue that they learned from Skylab is that it's important for Mission Control not to micromanage the astronauts' time. They should not give them a minute-by-minute timeline telling them exactly what to do and when to do it. What they should do is give the astronauts a series of tasks and let the astronauts figure out when the best time to do that task is. It makes the astronauts happier and it makes them more productive. Skylab eventually burned up, so the hope was that the space shuttle would be ready in time to boost Skylab to a higher orbit so that we could continue to use it as a space station. But it turns out the space shuttle was delayed and it wasn't ready in time, and Skylab re-entered on July the 11th, 1979 over the southern Indian Ocean and Australia after almost 35,000 orbits of the Earth. And a couple of the really big pieces did survive re-entry. Some of them landed in Australia, and the Shire of Esperance fined NASA $400 for littering. The Soviets at this time also were launching additional space stations. We had seen Salyut 1 and then Almaz 1 and 2, the first two military space stations, and then they had a number of other civilian and military space stations. Salyut 4, which was civilian, Salyut 5, Salyut 6 space stations, and then the longest lived of them was the Salyut 7 space station, which was in orbit from April 1982 until February of 1991. There were 12 visits of Soyuz spacecraft. 12 Soyuz crews visited Salyut 7, and the longest stay was 237 days. This led the Soviet Union to build the Mir space station. Now, I want to point out, it's important to realize that at this point, the Soviet Union has built and flown 7 space stations into orbit. The United States had 1, Skylab. The Soviet Union built 7. At this time, then, the Soviet Union builds another space station called the Mir space station. And this was a new design. Up until this time, the early space stations were all launched in a single piece, and they were all a self-contained unit. Everything the astronauts needed were in that one unit. In the case of Mir, there was a core module that was self-contained, but then the Soviets kept adding to it, and it was the first ever modular space station. In fact, it was the inspiration for the International Space Station, where instead of trying to launch everything at once, you would launch individual modules, and then you would hook those modules together once they were in space. Mir was constructed over a series of 10 years, and at the end of its life, it consisted of 7 pressurized modules, and it was continuously occupied for 3,644 days, or nearly 10 years. Mir was the home to the longest human spaceflight on record. Valery Polyakov spent 437 days, 18 hours in space aboard the Mir space station. Mir was also the first space station, the first international space station. Let me phrase that differently. The Soviet space station that the U.S. visited with 11 space shuttle missions. The United States and the Soviet Union and then Russia signed an agreement that would allow U.S. astronauts to visit the Mir space station. In fact, in 1995, the space shuttle docked with the Mir space station, and U.S. astronauts would spend many months aboard the Mir space station. A total of 7 U.S. astronauts. That's just to show you how crowded living is in a space station. That's what the interior of the core module of Mir looked like in 1997 aboard STS-84. So you can just see tubes and wires and everything running all over the place in the core module. So you can see here, this is essentially the module where there are many other modules docked to it. It's this one right here that's right at the center with all the other modules docked to it. All right, there's a picture of U.S. astronaut Shannon Lucid. She spent 6 months on Mir, March to September 1996. After construction of the International Space Station began in 1998, Russia had limited resources, and their limited resources were split between Mir and the International Space Station. So they decided to bring Mir down in a controlled reentry over the Pacific Ocean on March the 23rd, 2001. And I'm going to show this quick video clip that shows Mir re-entering over the Pacific. So there it is, burning up at very high altitudes, traveling, of course, at orbital velocity. So that's what the space station looked like. You can see that it had already, by this point, started breaking apart. And, of course, lots of pieces survived, but they landed in the Pacific. So what's the history behind the International Space Station? That was begun in 1984 as part of Space Station Freedom. President Ronald Reagan announced in his State of the Union address that the United States would begin construction of a permanently crewed space station called the Space Station Freedom. And at this early stage, there were 4 partners: NASA from the United States, the Japanese Space Agency JAXA, the European Space Agency, and the Canadian Space Agency. And it was seen as the next logical step after the space shuttle. Unfortunately, between 1984 and 1993, the space station was redesigned, and then they started over and redesigned it again, and then they threw that out and redesigned it again, and the budget got cut, and the budget got cut again, and the budget got cut again, and ultimately the United States was never able to realize the space station freedom as it had originally been envisioned. So by 1993, the program was a disaster. It had been almost canceled a number of times. The budget had been cut many times. It had been redesigned many times. So President Clinton announced a collaboration with Russia to combine plans for their second space station, Mir 2, their Mir 2, which would have been, I guess, their 9th space station, with plans for the Space Station Freedom to build one called the International Space Station. And this cooperation led to the first piece of the International Space Station being launched in 1998, and that was the Zarya, which is Russian for dawn, the Zarya functional cargo block, which formed the first part of the space station launched into space. The station was completed in 2011 with the very last flight of the space shuttle. And altogether, it took 2 Russian Proton rocket launches, 37 U.S. space shuttle launches. And remember, the space shuttle flew 135 times, so that's about a quarter of all the space shuttle flights were dedicated to building the International Space Station. It took about 160 spacewalks to build the space station with a total time of over 1,000 hours, and the total cost has been about $150 billion. Today, the space station consists of 16 pressurized modules and an interior volume of about 35,000 cubic feet. Its total mass is about 420,000 kilograms, just under 1 million pounds. And the first crew, Expedition 1, entered the space station on November the 2nd, 2000, and it has been continuously occupied nonstop since November the 2nd, 2000, at least as of the recording of this lecture. So here's what the space station looked like in the early days. This is the Zarya module, the functional cargo block that the Russians launched. This is Unity 1, Unity Node 1. That's Unity Node 1, which was the first piece that the United States launched to the International Space Station, brought up on a space shuttle and docked to Zarya. And then the Russians launched a second part. Zvezda was the second main part of the International Space Station that they launched. And over time, you can see as the International Space Station grew in size. The first giant solar array was launched to the International Space Station. And then as the space station grew, more modules were added over time. And then they began the building of what I would call today the backbone of the International Space Station. The backbone of the space station is a long truss that runs the length of the station. The 4 giant solar arrays are attached to this backbone, and the S0 truss, the main part of that truss, is attached to the U.S. Destiny laboratory. So after Destiny, the U.S. laboratory was brought up to the International Space Station, and that was docked to, that's the U.S. Destiny lab right there, which was docked to Node 1, which was docked to Zarya, which was docked to Zvezda, with the solar arrays on it there. They mounted this S0 truss on the back of Destiny. And since then, or after that, they started building the truss out on both sides. Once the truss got out to its full length, they were able to start adding solar arrays out to the end of the truss. To give you an idea of scale, here are some astronauts doing a spacewalk working on that truss, just to show you how enormous the truss itself is, how big that backbone is. Eventually, it was completed out to its full length on both sides. That set of solar arrays that had been mounted here on the Russian side of the station was then eventually moved out to its side on the edge there. More solar arrays were added. More solar arrays were added. And since then, additional modules have been added to the International Space Station. Today, I would argue, you could break the space station into sort of 3 main parts. There's the truss, the backbone of the space station that runs there, that has the 4 giant solar arrays attached to it. Underneath the trust, which is attached to the U.S. Destiny Laboratory, there is a Russian side of the space station and and everyone else side of the space station. So the Russian side has the Zarya functional cargo block and the Zvezda service module that are on the Russian side of the space station. And then on the U.S. international side, there is Node 1. There's the U.S. Destiny Laboratory. There's Node 3. There's a multi-purpose logistics module. There's an airlock attached. There is a European Space Agency Columbus orbital facility, a Node 2 that the United States launched, a Japanese experimental facility, and then a Japanese logistics section. So that is the U.S. and then international European Space Agency and Japanese side of the space station right there. And then actually down on the bottom of the space station down there is the cupola, which allows them to see the Earth. So here's a sort of a schematic of what the space station looks like right now. So there's the backbone of the space station. All of these habitable modules are located here underneath the backbone. And again, this is the Russian side over here with Zarya and Zvezda. These are where the Soyuz spacecraft and the Progress resupply vehicles dock to the space station. And then on the U.S. international side, here's a picture of what it looks like. And again, this is a computer animation. This is not an actual photograph. This is where the Crew Dragon can dock to it. We've got a Cygnus resupply vehicle docked right there. This is the U.S. Destiny Laboratory right there, the U.S. Destiny Science Laboratory. Node 1 right there, Node 2 right there. We've got the Japanese module here and the European module right there. All right. And so this is an actual photograph of the space station in orbit around the Earth. And this is what it looks like today, about the size of a football field up there in orbit. The primary use for the International Space Station is conducting science and engineering experiments in the weightlessness of low Earth orbit, or what we would call a microgravity environment. There are things that can be done in low Earth orbit in weightless environments that can't be done on Earth, and those experiments are being carried out on the space station today. But I think for a mission to Mars, by far the most important thing we're learning about spaceflight learning about human spaceflight on the International Space Station is how to keep a crew alive and well, and how to keep them productive and happy during long missions. Today, a mission on the International Space Station is typically about 6 months long. A mission to Mars will be about 3 years long. So the astronauts are not spending as much time on the space station as they'll be spending on a mission to Mars. We have had a number of astronauts now spend almost a year on the International Space Station, which is about as how long it will take for the first crews to get to Mars and how long it will take them to return. And what we're learning from those long duration missions is how to keep astronauts healthy for the year that it will take to get to Mars, where they may be in weightlessness the whole time, and the year that it takes for them to return home. Now, it has gotten busy at the International Space Station. In fact, it's so busy that most people don't even notice what's going on. In a typical year at the International Space Station, there will be 4 crew launches going up to the space stations, typically 12 people up, and then 4 crew returns, 12 people coming down. Right now, I should say up until this past year, we've been using the Russian Soyuz vehicle to do this. We've now had 2 Crew Dragon missions. The 3rd Crew Dragon mission is coming up. The 2nd functional one is coming up here in a couple months, or in about a month. There have been, in a typical year at the International Space Station, there will be about 10 resupply missions. These are uncrewed spacecraft that are used to bring supplies to the International Space Station. So there'll typically be about 3 Russian Progress vehicles, 2 typically U.S. Northrop Grumman Cygnus missions, 4 SpaceX Dragon cargo missions, and every now and then a Japanese cargo mission to the International Space Station. And in a typical year, there'll be something like 10 spacewalks totaling about 65 hours. And it's important to remember that the space station has been continuously occupied nonstop since November of 2000. As I mentioned, I think early in the course, you are the first generation of college students who have lived your whole lives with people who were living and working in space. When I was young, people would launch to space and then they would come down, and many weeks would go by with nobody in space, and then someone would launch and come back, and many weeks would go by, or months I should say, would go by with nobody in space. If you are under the age of about 20 and a half, if you were born after November of 2000, you have lived your whole life with people living and working in space. And that's the first time in human history that we can say that we have had a continuous long-term presence in space. I think ultimately that is going to be the lasting legacy of the International Space Station. If you're interested, I highly recommend this tour of the International Space Station given by Sunita Williams. She will take you through all the modules on the space station. You will see what it's like to live and work on the International Space Station. It really is a fantastic tour. There are 4 parts to it. And it takes about an hour to go through the whole tour, so I'm not going to take you through it now. But if you're interested in learning more about the space station and what it's like to live and work in space, I highly recommend that you take a look at all 4 of her videos on living and working in space. So that ends my introduction to the International Space Station. In our next lecture, I will talk about modern launch vehicles. What are some of the launch vehicles that we're using to get to space today? And then after that, we will talk about the current ways that we're getting humans to orbit with the current human spaceflight missions. So I will see you in the next lecture, Lecture 10.